Hello everybody, I will start with another coding practice. So in this video, I will solve the question coin change. And actually in my previous video, I solved this with top-down dynamic programming. However, I couldn't say it was a good video because I was stuck in front of the video and sorry, in the middle of the video. And also after finishing it, I found that I can, you know, explain more concise way. So I decided to post this video again in top-down dynamic programming. Okay, so let me read the question. So in this question, I'm given an integer array coins, and this represents coins of different denominations. And also I'm given an argument integer amount. This represents the total amount of money. Okay. And my task is to return the fewest number of coins that I need to make up that amount. Yep. If that amount of money cannot be made up, then I will return -1. I may assume that I have an infinite number of each kind of coin. Okay, I can choose any number of coins for each. Okay, so that being said, um, let me clarify the question statement first, as usual. So in this question, I'm given an array of coins and also integer amount. And yep, I will try to make up the amount, total amount, with the coins. So obviously, my first question is amount can be negative or not. And the second question is, if there is, I mean, is it possible that coins array is empty? So when I take a look at the constraint, I can find that constraint is one or more, so it cannot be an empty array. And for amount, it should be 0 or more. So yeah, it cannot be empty. I mean, it cannot be negative. Okay, and obviously if the amount is 0, I should return 0. Yeah. And if the coins is no, it's okay. Yep, that's it. So that being said, I will think of this question with some examples. So in this example, I will choose coin $1, $2, $5, and I will try to increase the amount $11. So let me think how I can, try to make up the total target amount. So the first thing I can do is I will think how many $5 coin I should use. And there are three possibilities. Number one, I choose 0 $5 coin. Number two, 1. Number two, 3, 2. Yep. And for each, I can say the remaining coin is $6. And for the second, I can say this. And that being said, what should I do? So, I will try to make up this amount with the remaining coins, 1 and 2. Because for $5, I thought of every possible number of coins. So I don't use $5 coin anymore. And I try to make up with only $1 and $2 coins. And what I can find from here is that I'm solving the quite similar question to the original question. Originally, it was I have $1, $2, $5, and I try to make $11. And now I'm currently solving 3 sub-questions, sub-problems. which is the first one of which is I have $1 and $2 and trying to make up $11. How yeah, what's the minimum number of coins I can use to make up? So obviously, um, I can use the result of the subprogram plus 0. Then I guess the original question's answer candidate. And I will do the same for $5 coin count 1 and count 2. And and the minimum of them is, answer this question. So from this, I can say that I'm dividing the question into subprograms and trying to solve it. And with the result of them, I'm trying to solve the original program. So I definitely I can use the dynamic programming here. Yeah. Also because the subprogram, the results of the subprogram can be memorized because the result never changes. Yeah, once I calculate it. So in that way, I can avoid the redundant words. Yeah. Okay. So that being said, yeah. Now I will think of the top-down DP's recursive function. Yeah. So obviously, the problem I want to solve is possible coins and trying to make amount. This is what I want to solve. I have limited number of coins, limited kind of points. Then I can try to make up the amount. Yeah, this is interface. Okay, for the implementation, I will think of it later while I'm implementing it. But I just wanted to clarify the interface first. And also, there is one more approach, or I should say one more interface I can use to solve this question in top-down approach. So it should be like this. I would just think how much amount of money I'd write to, total amount, target amount only in the recursive function. So in this way, I can choose any of the possible coin, 1 or 2 or 5. Even after choosing 5 first, then in the subprogram, I choose coin number 2. Then in the subprogram with that, I can choose $5 coin again. It's possible in this approach. Yeah. And I will explain each of them while implementing, but I can say either of them works. But this needs a bit of optimization or technique. Okay, so I will introduce that while I'm implementing. Okay. So that being said, let me start with this one first. Yeah, like this. So this line 25 max count is a recursive function. Yeah. And I will call it with the target amount in the end in line 28. And now my task is to implement the max count. Yeah. So for the base case, if the amount is 0, I should return 0. However, if amount is negative, then I should return, because I cannot make up negative amount of money, I have to return -1. Yeah, because that's what is expected to be returned when I cannot make up the money. So these are the base cases. And now we're think how I can make this amount. So I will think of each case. I will think of the cases in each of which is to choose $1 coin, $2 coins, $5 coins. So each type of coin. And yep. So my next task is to, create the amount minus coin amount. Yep. +1. So this is the count. Yeah. So if I choose this coin in line 31, the minimum, sorry, not max count, minimum count. Minimum count of coins is this. Okay. So I will return the minimum of them. Okay. But one thing I have to take care is the mini count returns -1 in the case the coin is not, make generatable. Amount is not generatable. In that case, -1 + 1 is 0, so it is just counted as, possible way. So I'd like to avoid it. So if I cannot create the mini count, I will return none. And I will say like this. Yep. Then I will. The remaining count is none. I just skip it. Okay. Yep. Good. And one thing I have to take care is before returning this read can be mass infinity or integer. Yeah. So if it is, mass infinity, it means that I couldn't make up the target amount in this recursive function, so I should return none. And then line 41, yep, I have to take care of the none. Like this. Okay, so let me walk through my code with coins 1 to 3, 1 to 5, and then 1 to 11. So for 3, I call, mini count amount with 11. In this case, amount is not 0 and amount is not negative. So I go to line 35 and return is now mass infinity. Then I will take a look at each coin. So firstly, when I choose the coin 1, remaining counts should be mini count, amount minus count, which is 1. And so count should be +1. So this is it. And same for the cases I choose 2 or 5. Yeah. Okay. And now my task is to find mini count 9 and minimum count 10 and minimum count 6. So I will think mini count 6. So minimum count 6 is, for example, I have 5 choices. Yeah, like this. So I can do it in this way. Yeah. So that basically how it works. I don't work through the whole code because of the time limitation, but basically it works. Let me just confirm about the non and mass infinity and -1 check. So in this method, if target amount is not generatable, I return none here in line 40, and in line 50, I return none. Then in line 53, I confirm that none is converted to -1. Yep, it's okay. Wait, but one thing I've noticed is that I think I can just return mass infinity if not generatable. I think this makes things much easier. I don't have to do this check. I think this works. Yeah. Then in line 48, I just have to return read. So now mini count can be mass infinity. In that case, it should be converted to -1. Okay, let me run my code. Okay. What's the problem? Cannot access local variable count. No, this should be coin. Good, I submitted my code. Okay, now it's accepted. So let me talk about the complexity analysis of this solution. So for time complexity, firstly, I will take a look at the argument of this recursive function. So this has only amount, and this amount can be 0 to given amount. Yeah. Even though it can be negative in some cases, obviously amount is much bigger than each coin. In many cases, I can just ignore it. Yeah. So I can think of the amount. Yeah. So, and that being said, I will think the time complexity in this recursive function, it should be all of number of coins, because in line 46, I iterate for each coin. And aside from that, all the operations takes constant time. So the time complexity should be amount times number of coins. Yeah. Okay, let me say So this is a time complexity. Because once I calculate the mini count of specific amount argument, that would take only the constant time from the next time. So, yeah, I can think how many times this mini count is called with different amount, and then I have to calculate it with the, time complexity of the inner implementation. Okay, and for space complexity, so what I need is the cache, which is up to amount keys. And also I will think of the recursive function recursion stack. It can up to m again. It m because let's think that I choose one coin all the time, every time. In that case, the recursion should be amount number of times. So that's the maximum of the recursion stack space complexity. Yep. So then in total, wait, what did I do? No, this is m plus m, so this should be O of m. Okay, so this is a space complexity. Now I will try to work on the second approach. So okay, now I will think of the possible coins and amount. So in this case, in each recursive function, I choose the specific coin only, just like I showed in the first example here. In this case, I had three choices: choosing coin 0 times, choosing coin 1 times, choosing coin twice. Yeah. And for each, I define the subprogram as I will try to make up the remaining amount with only remaining coins, not $5 anymore. That's another approach I can use. Yeah. I will implement this. So quick technique I use here is that I don't pass the possible coins list, but I will pass the end index of the coin until which I can use coins. In that way, I can optimize space and time complexity. Okay, from here, so basically the base case is the same. And from here, I will think how many coins I can choose. So last coin, the coin I'm thinking right now is this one. And I will think how many coins I can choose. And the remaining amount is Okay, I can say like this. Oh, and because in line 54, I make sure that, count never exceeds amount. So I can say in the base condition, amount is larger or equal to 0. Okay. And also I have to think of the case when end coin index is -1. So the base case should be like this. Yep. Okay. Now what I would do is I update the return with total count. Yeah. So in this way, the minimum of total count is returned. If there isn't, I return mass infinity. Okay. Good. So with this approach, the time complexity should be okay. Firstly, for line 45 from the interface, and coin index can be 0 to no -1 to n-1. So there are n variable possible options. And for amount, it can be 0 to amount. So there are amount, which is m number of options. So by multiplying them, there are nm combination of arguments. And for each, the time complexity of the operation inside of this recursive function is, because in line 53, I iterate with, amount divided by count. So let's think that the coin is very small compared with the amount I try to generate. So in that case, I will assume that this is m steps almost. So it should be m. Yeah. So multiplying them, and m squared is the time complexity. But this is not so good. Yeah. I actually can. So when I submit with this, oh, I made the same mistake again. This is accepted, but this is now time limit exceeded actually. Yeah. So I have to think of the optimization approach. The optimization I can make from here is that I actually know how I can do it. So let's think of this for loop. Do I really need this for loop or not? Actually, I don't need it. So let's think of it in this way. Here, I have 1 to 5 coins, and I have the option to choose 0 or 1 or 2 $5 coins. And when I pick, you know, yeah, 0, only no $5 coin, in that case, yes, the subprogram is generating $15 with only coin 1, 2. But let's think when I pick up only one $5 coin. So in that case, the sub-problem is like I'd like to generate $6 with coin $1, $2. But this is also the same as, well, how should I say? So I'd like to generate $6. Yep. Mm. So what I want to tell you is, okay, let's think that I choose, okay, let me say it in this way. So for line 9 and 10, I generalize these cases as I pick one $5 coin, and then after that, I will choose $1 or $2 or $5, any of these $3. So in that way, I don't take care of the case when two $5 coin is picked up twice. However, I think of this question and firstly, I think of this question like firstly, I pick one $5 coin and the remaining is $6. And I can still choose $5 coin. Then, in the case when I choose the $5 coin one more time, the sub problem should be try to make the $1 with $1 or $2. So I could generalize this question into two, options. I don't choose any $5 coin, or I will choose at least $1 coin. And in that case, my task is to try to generate the remaining $6 with $1 or $2 or $5. I can choose $5 again. Yeah. So that's the optimization I can make for this question. So let me implement it. So here in line 63, I don't do this, but yeah. So when I think of choosing no and coin, what happens is that okay, I try to make up with in this way. I just remove the option of the last coin and I still try to make the same amount target. This is, and when I choose one or more end coin, it should be like this. Where is it? So boom, coin, yeah. Just like I told you before. But I try to make sure that coin never exceeds the amount. So let me update. And my task is to return the minimum smaller one of these. Or maybe both of them is infinity, then I should return infinity. Okay, this is it. Yeah, so this is the optimization I can make. So let me quickly review it. Mini count and coin index minus one amount. Yes. Or mini count of end coin index and amount minus coin. Okay. I'm pretty sure I execute code. Oh. So now this returns 0. Mm. So all of them is 0. Oh, sorry, I forgot to do something. Here in line 74, I have to plus 1 because I chose 1 and the coin here. Good. Now I execute my code. Great. Okay, so I quickly right. So the time complexity of this approach should be O of nm because in line, I mean, I could remove the for loop at line 64. So internally, this recursive function takes the constant time. So the time complexity should be nm, which is exactly the number of possible combination argument. Okay, let me quickly wrap up on today's practice. So in today's video, I solved the question coin change. And I solved this with top-down dynamic programming. And I introduced two approaches, two interfaces of recursive function. For the first one, it was quite simple. But for the second one, I had to do a bit of optimization technique so that it doesn't time limit exceeded. Yep. About this question, so I was given the possible dominations of coins, and also I was given the target amount. And my task was to find the minimum number of coins to make up the given total target amount. Okay, so that was it. So I finished my today's coding practice with this. Thank you so much. Bye.